Hi, hello friends, welcome to my YouTube channel. So this is Arif. Now I am going to present the previous APPSC AEE screening test answers. We are discussing the part 3 of this series. The first question here it is: the rotor of a squirrel cage induction motor is open, the motor will. Generally, for a squirrel cage induction motor, so we are giving the input energy to the induction motor here. Now this, because of this, there is a flux which is rotating at a synchronous speed here. So inside there is a rotor which is of squirrel cage. So squirrel cage means it is like this. Okay, so it is closed at the both the ends here. Okay, short circuited. Now if it opens means what will happen? So because of open circuit here, the current will not flow. The current will be zero in the rotor. Because of that, the flux flowing in the rotor will be zero. So there will be no interaction, so that the motor is not going to be run. So the option here it is 4. It is not going to run. Next question: the ABCD constants of short transmission line are. So here we can cross check these values by using the shortcut formula. There is a reciprocal of the transmission line. AD minus BC is equal to 1 is the one way, and the second way to eliminate the options is for a short transmission line. For short transmission line, the capacitance value will be 0. So among these options, the capacitance will be 0 in these two options. After that, you can apply this concept AD minus BC is equal to 1 for reciprocal of the network. Then you will get the answer easily. Next question. Here, the ABCD parameters of a medium length lines in a normal T configuration is. So normally in a T configuration, what the ABCD values will be. So A is equal to 1 plus YZ by 4 is the A value, and B value is Z into 1 plus YZ by, sorry, here mistaken, it's a 2 and here it is a 4, and C will be Y. So D is equal to 1 plus YZ by 2 here. So these are the options here. Okay, here it is a 2, okay, and here it is a 4. Now among the given options, no option matches this answer, so answer will not be for this marks. We will get an extra guess mark for this question here. Okay, so A value is 1 plus YZ by 2, B is equal to Z in 1 plus YZ by 4, C is Y, and D is equal to 1 plus YZ by 2 here. And the next question: the meter constant of a single phase 240 volts induction watt hour meter is 400 revolutions per kilowatt hour. The speed of the disc for a current of 10 amperes of 0.8 power factor lagging will be. So in this question we need to find the number of revolutions made by the induction made by this meter here. The formula here is number of revolutions in RPM. So number of revolutions in RPM is equal to, so first of all we take the K into VI into cos Y divided by 1000 into 3600 into 60. So here was the value of K. So K is nothing but 400. The voltage is 240. The current is how much here? 10 into 0.8 into 60 divided by 1000 into 3600. So if you could do this, we get the answer as 12.8 RPM is the answer for this question. So let's move to the next question. Calculate the following circuit. What is the value of the current I is shown in the figure. So I will zoom it a little bit to see the diagram here. Now here we need to find the current here in this case. So how we are going to do this one? See here, we can apply the bridge balance technique. Okay, so we can apply the bridge balance technique here. So according to bridge balance technique, the opposite arms are opposite resistance are balanced, means there will be no current flowing here. For example, here we have a 3 into 6 18. So 3 into 6 is equal to 6 into 3. So 3 into 6. So it's a bridge balance, means there will be no current flow here. And similarly here also we can cross check 3 into 2. So 3 into 2 here. So this 2 and is equal to 3 into 2. So because of this, there will be no current flowing in this element. So if you remove this element, and if you draw the equivalent circuit here, it will be like this. So here we have a 2 ohm resistor, another 2, so in parallel with 3 and 3, and similarly 6 here. So whatever the resistance between these two elements is going to be 0 because of the bridge is balanced here. Now here we have a source voltage of 6 volts and we need to find the current here. So simply we can do this one. So what will be the equivalent here? 4 is in parallel with 6 is in parallel with 12, and there is a voltage source of plus or minus 6 volts here, and current flowing here it is I. Okay, so here 12 volts means 6 volts is here. So how much current will flow here? So by applying this current division rule, we can calculate the current as it is going to be I is equal to 3 amperes. So answer for this question is 3 amperes here, as you can apply KCL here. So for example, take here in this element, so 6 volts here, how much current will flow here? So it's going to be half amps. So here is going to be 2 amps, and here is going to be 6 by 4 like this. Okay, so the answer is 3 amperes for this case now. So we'll move to the next problem. Next case here. Wait a minute, let me adjust this resolution. Alright, a moving iron voltmeter is connected across a voltage source whose instantaneous value is V of t is equal to 5 plus 10 cos 314 plus 30 degrees. So the reading of the meter will be, so moving iron meters will read only RMS value. So moving iron instrument will read only RMS value. So V of t RMS is equal to square root of, so this is the average value now, so 5 whole square plus 10 divided by root 2 whole square. So this is equal to square root of 25 plus 100 by 2. So there is nothing but square root of 75 amps is the RMS value for this question. So answer will be 1 here. Next one. The DC generator runs at a speed of 1000 rpm and the flux per pole is 0.25 webers. The number of poles are 2. The winding is wave wound and having a conductors of 480. The critical speed is going to be 1200 rpm. Okay, critical speed is going to be 200 rpm. Then the generated EMF will be. So here the condition to be satisfied for the production of EMF will be, the first one, the rotor speed, the motor speed should be more than its critical speed, and second one is the rotor field resistance should be less than its critical field resistance. So here the first condition is failed. Why? Because the machine is rotating at 1000 rpm, its critical speed, it means above which it's going to produce EMF, is going to be 1200 rpm. So here the machine is not going to be self-excite because its speed will be less than its critical value. So there will be no EMF present here. Okay, so the answer will be 10 volts here. Next one here, the losses for a lossless line, the characteristics impedance is having L is equal to 1.8 millihenry, Z is equal to 0.02 microfarad will be. So here for this question, the characteristic impedance ZC is equal to square root of L by C, which is nothing but square root of L is nothing but 1.8 into 10 power minus 3 divided by 0.02 microfarads. So if you solve this, you may get the answer as 300 ohms. So answer here it is 4. Okay, and the next question, the synchronous speed for a 3-phase 6-pole induction motor is 1200 rpm if the number of poles are now reduced to the 4. Okay, with the frequency remaining constant, the rotor speed with a slip of 5% will be. So we need to find here the rotor speed of the induction motor. So first of all, what's the speed they given? So the speed what they given is Ns is how much? 1200 rpm. So Ns is equal to 120 F by P with the number of poles are 6. So from this we can calculate F as a 60. I guess you can substitute directly here. So 120. So NS is 1200 into P means 6. So we get it 60 Hz. And similarly, what we need now, the poles are reduced. So now the poles are reduced means what is the speed? NS is equal to 120. Frequency is 50. We got it now here itself. By how many number of poles? The poles are reduced by 4 here. So now the speed is going to be 1800 RPM. Okay. Now we need to find the rotor speed. So we know the formula. NR is equal to NS into 1 minus S, which is equal to, what's the value of NR? So it is going to be 1800 into 1 minus 0.05. Okay. So from this the answer will be 1710 RPM. So this is the answer. So that's it for this session. Thank you friends. Thanks for watching my video. If you like my video, please subscribe, share and comment. Thank you.